So RemoteBridge, this is a platform which we have developed for connecting the strategists and the process experts to the operations of the plant. This is the agenda I'll be covering today. So without miss, let's proceed ahead. Facts at a glance about Raj. We have more than 1,000 plus references. We are present in about 100 countries, 400 plus overseas references. We have 4 manufacturing facilities, 3 in Maharashtra and 1 in Gujarat, 1,200 plus employees, 90 plus research scientists, and we have 300 plus patents. 40% of our business comes from repeat customers. Our global ethanol production, we contribute about 10% of it, excluding China. Been in business for more than 38 years now, and 24 years of regular dividend payouts for all our shareholders. We are a $200+ million company. Our beloved chairman, Dr. Pramod Chaudhary, he received the George Washington Carver Award in 2020. Is the first Indian to receive it, and this is for innovation in industrial biotechnology and agriculture. And this is some of the accolades we have got from Biofuel Digest, best place to work, and then number 2 in renewable fuels, chemicals and biomaterials, and then biodesign and engineering organization. That's about our company in brief. I'll start with the Industrial Revolution. We are all familiar with the first Industrial Revolution, where James Watt started with the steam engine, and then we have the second Industrial Revolution, which was the Cincinnati slaughterhouse, where we had the first assembly chain. This was the advent of the mass production. And then the third Industrial Revolution started using electronic systems and IT systems in their early days, where we had the programmable logic controllers, which are still in vogue in all the industrial automation. Fourth Industrial Revolution started connecting the devices through the internet, and the degree of complexity, as we see, started growing from Industry 1.0 to 4.0. Going ahead, we all know the basket of technologies which are used in Industry 4.0, right from robots, so on and so forth. And my next slide talks about the categorization. If you connectivity, data, computational power is one category, analytics, intelligence, the other, human machine interaction, and then advanced engineering. So these are the various technologies which have started emerging as a part of Industry 4.0 foundation. On one side, this was happening. While technology is very important for doing business, what is paramount for doing business is customer centricity. So which is a must for Industry 4.0 and above. What is customer centricity? Customer centricity is nothing but putting customers and their end customers at the center of your thinking. So as an industry, we try to think about what the customer benefits. So typically, we need to think about how we can enhance customers' business, how we can help them take timely actions, how we can ensure that their systems are up for most of the times, thereby reducing their cost of operation. And in turn, the industry also benefits, because the benefits have to be mutual. And then only we will be in a position to survive in the market, to serve our customers. So it gives us the market leadership. It helps the industry to bring value to their customers. And it also provides insight to innovate and improve, so that we can better the solutions we are offering to the customer. So this is in essence a customer centricity. So each of us, so if Praj is the industry to start with, then Praj's customer is on the left hand side. But then again, you can further think about this by putting Praj's customer in the industry and extend it to their customers. So that is how customer centricity propagates, which is very important when we are delving into Industry 4.0 and above, because we are talking about huge scales of operation and economy of scales. So it becomes very important that the wave is able to propagate for a long duration. Now let's have a critical look at process industry automation, process industry automation. I were to say the 1 and 2 of it started off with local control panels, where we had, the push button stations with the mimic diagrams, and we used to operate the plant from these kind of stations. This then evolved into a programmable logic control based systems, and we started having what is called as the SCADA system or the HMI, human machine interface. So on the left hand side, you see the typical SCADA system, which is used for operating the plant through the PLC system. If you take a broader look of it, so you had the SCADA and operator workstations connected on the local LAN, and we had the programmable logic controllers operating the plant connected to the same network.
So yeah, you're still on the first slide.
But for me, it is showing this thing.
So 1 second.
I think it's on the PowerPoint. What you do is you share the end.
Yeah.
Yeah, let's share the entire screen. Yeah, go ahead with the entire screen. Now we shall do it. Now we are able to see the screen change.
Yes.
Sorry about it. This was the facts at a glance of Praj, what I had talked about. I'll give you a minute for you to catch up on this. Then we talked about the industrial revolution, how the industry 1.0, 2.0, 3.0, and 4.0, basically giving the snapshots of those. Then we just briefly touched upon the various technologies and the categorization of various technologies used in Industry 4.0, connectivity, data, computation power, analytics and intelligence, human-machine interactions, and advanced engineering. Going forward, we said that customer centricity is very important for Industry 4.0 because we put up any industry to serve the customers. And what the customers are going to benefit out of what solution we offer is paramount. So the customer benefit we have to think through in these following dimensions, like how we can improve their productivity, how we can enhance customers' operations, take timely actions, how we can ensure that their operations are up for most of the time, and also help reduce the cost of operation. And in turn, the industry gets benefit. The companies become the market leader, they add value to their customers, and therefore their customers start recognizing them, and the industry is able to offer insight and further the solutions by innovation. Right? So this is how this wheel of customer centricity helps the economy to propagate and expand. And then we talked about the industrial automation in the process industries, especially how we started with the local control panels. That led then later on to PLC based control systems, programmable logic controllers, and the SCADA systems and HMIs. So this is the broader landscape. This then started giving rise to 4.0, where we started having the SCADA system, the local network, operational network, getting connected through gateways to data systems on the cloud, the data centers, thereby furthering the information availability to the customers through web and mobile interface. You get alerts and emails for users, and it also makes the life easier for analysts to sift through the data and give recommendations. So this is what was happening in the process industry automation evolution. Now I talk about how we went about defining the remote bridge solution. First, we thought about our customers' need. What are the three basic customer needs? So we found that our customers, they have to deliver quality, quantity, and on time to their customers in turn, whatever products. Typically, we are in the bioenergy space, so we put up plants which are, delivering biofuel ethanols to the industry, to the market. So our customers, they would expect quality ethanol and in good quantity, and it has to be running almost 24 by 7, 360 days. So this is the prime expectation. And second is they need to get actionable insights on the process. What is happening in the distillation columns, what is happening in the evaporation segments, what is happening in the fermentation section. These are some of the key insights which they will look forward, actionable insights in the process and the operations and management of the plant. Are we attending to the alarms on time? What are the critical alarms? How do we maintain the plant? These are some of the important actionable insights they look forward. And third, why they need all these two is basically because they want to sustain and maximize value to customers, partners. The customers are also interested in making their employees' life easier, and they need to interact with their suppliers, associates, and they also need to take care of the planet. So we leave a good planet for our future generation. So these we identified as the three primordial dimensions we need to deliver on. So with this as the central thought, we looked at what is the technology has got to offer. So if you look at Industry 4.0, then we have the sensors to sense what is happening in the plant. We have the computation and computing power to make sense out of it, and then we can advise sense to the customers. And this being a remote bridge, we are not doing any control actions of the plant because of, there will be health, safety of individuals involved in the plant operation. So therefore, we restricted ourselves to only sense, make sense, and advise sense of what is happening in the plant. So this is a pictorial view of what type of process plant we put up for our customers. So we looked at this and we looked at our customer requirements, and we looked at the as-is process, what was happening in the process industry. So when we look at the as-is process, it is more scattered, manual, and it is slow. So basically on the left-hand side, you have the SCADA system, then you have the laboratory, and then you have the operator. So basically these are the three streams of information which are collated manually by the plant management. So the plant managers have to, get data from all these three streams of operation. Basically, the operators sitting in the control room operating the plant, and then the chemists who are doing the analysis of the samples which are flowing through those pipes, and sitting in the tanks, both at the input as well as at the output, and then the operators who have to take actions on ground and then report what actions they have taken. This was either a fully manual or a semi-manual methodology by which the plant manager has to assimilate the information, and then they have to provide it to their strategic management. Basically, if there are multiple plants, the strategic management was looking at information from many of their plants simultaneously, which was difficult, and it's a manual compilation, so there's a lot of time loss. And the process experts, if any of our plants were to call a process expert to improve upon the process, or if they are going through some bottleneck, the process experts also, for them to get the data and then do the analysis was taking a lot more of time. So this is the as-is scenario which is happening in many of the industrial process plants. We looked at this, and then our thought process began as to, okay, fine, if this is the situation in this context, how we can leverage Industry 4.0 and deliver a reasonable solution for our customers. So then the thought process began. How do we connect with process, operation, and management? That is something very critical. And then how do we help create value for our customers and their associates and their ecosystem? And this we thought as how to do it using the digital technology as well as the process technology. Here the process I am referring to is more like a chemical process which is happening in the plant. So again, with these three as the pillars, then we thought about what our solutions should do. So we said, if we take a Panchamrit or a Panchamrit style of analogy. Then we said first it should have a quick root cause analysis resolution, and that should be possible remotely, so we can cut down on the travel time of experts to the plant to solve the bottlenecks. Second, maximizing throughput of the plant by giving timely alerts for operations to take action. And then critical health checks and operating plant parameters for both plant managers, strategic management. And this will also, timely actions and interventions in the operation of the plant can lead to OPEX reduction and thereby contributing the profits. And for all of these things, we also needed to have information dashboard for decision making. So we said that our remote bridge should help in addressing all these 5 dimensions. And that is how we then try to bring in a framework. So now the to be, that is the remote bridge platform, which is a unified digital and it's an agile platform. If you see, we started getting the streams. The three streams are brought into remote bridge using digital technologies. And once we get it onto the remote bridge, then we do the processing through a customized application, remote bridge application, where the 3 streams are collated, and we try to get a holistic picture of the plant so that we can provide to plant management. So we can help the plant management do process and equipment maintenance in all 3 modes: preventive, predictive, and prescriptive. And then we can have proper workflows in laboratory and as well as the operations. So there is a workflow for maker, checker, and then submission of that data, so that that data can finally then be collated. And the plant management also gets critical dashboard information on in their offices or on their mobiles, so they can access this critical information from anywhere. So this will also help in the current pandemic times where we had less number of people going to the plants. So this also helps, the plant management to contribute remotely for the safe operation and a better operation of the plant. And simultaneously, remote bridge will also give a direct access for process experts also to log into the system and to start doing analysis of various parameters. They can do multivariate analysis. For example, they can do comparisons of different plant parameters to see what is the impact on different sections, and so on and so forth, and do a timely troubleshooting of the plant. The strategic management is also then helped with a dashboard. So sitting in the head office, if they are having multiple plants, they can have a holistic view of what is happening across their different plants. So thereby driving, better synergistic strategies for operation of their group companies as well. This is what we envisaged that remote bridge will be able to do for our customers. And now I will dwell into the architecture of remote bridge, because most of us come from electrical and electronics background. So we all know what is a programmable logic controllers which are operating in the plant. So you get the SCADA system. Basically, you see the SCADA. This is for a local decision making. So basically, the operators are running the plant. So it's like similar to a car dashboard, which is required for running the car. Similarly, the operation control system is required for running the plant. We establish a parallel gateway for the data flow from the PLC. So we take through the OT gateway, we take the digital snap of the plant. Every 10 seconds, we pull in the digital snap of the plant, basically all the IOs, digital input, digital outputs, analog inputs, analog outputs, and register values, which are getting generated in the plant. So that comes through to a OT gateway PC as well, where we are buffering the data and then we are pushing it through the internet to the server. So we have our own setup for our customers. So one customer, one server. So there is data confidentiality of each customer is maintained and security is maintained. And it is here that the processing algorithms work on the three data streams which you get. So first is the PLC SCADA, and then you are seeing the web terminals which are provided at different spots in the plant, like laboratory and the operation stations. And the plant manager also will be in a position to log in from here and view the trends of the happenings in the plant. So, and we at Praj Industries as well can help our customers by logging into the specific plant and look at the operations in a holistic manner and provide services to our customers. Authorized users can access the information based on their authentication and access controls from various devices as well. So this is the broad architecture uh, of our remote bridge system. So we are leveraging on various technologies like communication technologies, right from 2G to 4G and 5G probably when it comes through. And then we are having open source architectures, and then we are having the cloud computing, which is kicking in over here, and big data analysis also kicks in over here. And this forms the foundation for our future journey. In our next phase, we will be also introducing a smart version of Remote Bridge where artificial intelligence and machine learning will build on the data collected thus far and start providing valuable suggestions for the operation of the plant at all three levels. That is at the operations, tactical, and the strategic level. So this is the Remote Bridge architecture. The value proposition we bring to our customers is, because of the Remote Bridge, we are able to give on-time process alerts for at the management level, and then this helps for timely intervention by management in the operation of the plant, thereby enhancing plant uptime, which also then gives production empowerment to the operation team, and thereby also helping them to have a performance overview of the entire plant. All this is made possible by this four dimension approach, that is a customized smart application, leveraging of cloud technology, leveraging of communication technology, and these three getting augmented by the process expert knowledge and experience. So we handle the data in a very secure manner. It is very important. We take care of the cyber security aspect. We need to assure our customers, so our data centers are ISO and IEC 2701 certified data center, and the remote bridge applications are hosted in certified data center only. So this is the value proposition we bring to our customers. So this is all much about how we thought about what we need to do and what we did. So going forward, I will show you some actual, I'll be sharing some actual dashboards and visualizations to help you understand a little bit more about the remote bridge. Okay. So as soon as we log into the system, we will get to the process plant, and there we will have a sunburst chart, which is indicating various sections of the plant. Like for example, this is a renewable gas business. So the capacity of input capacity is mentioned right at the center. And then you have the business renewable gas. Then you have the various sections in the plant: anaerobic section, gas purification section, raw material, and so on and so forth. And furthermore, if you see, these are the radiance, the rays which are emanating from the sun, and each of this is an equipment in the section. So the analyst can go directly into the equipment they want to analyze, or they can go to the section, or they can have a pulse check of what is happening in the plant in one go. So this is the typical first landing page, and this is the typical sectional view. So when we go into the BURG process, it starts giving the various important parameters. It's similar to how a doctor, when he visits the patients, he likes to know what is the blood pressure, what is the stat oxygen level, and so on and so forth. Similar to that, when a process person enters into a plant, he would like to know what is the input rate, what are the consumptions, and what are the output rates which are coming in. So this is the kind of a dashboard. Here we have, he or she can view it on an hourly basis or a daily basis. one can choose the granularity, whether it should be in seconds or in minutes or in hours. And then we have the various sections. There is an option to download the information into Excel for further analysis. And on the online graph, we also have facility to do a rate of change study. So here, on clicking on this button, we will see that the curve changes to a rate of change. And then what is the normal operating band with both minimum and maximum is made available. This is the lab report which people will be entering it, and it goes through a workflow, sent for review, save to draft, send for review, and then there is approval and rejection mechanism. Now you see the data being entered for various sections, like this is for the anaerobic digester, and you have the solid liquid separation. So they try to measure the pH, total solids, total volatile solids, so on and so forth. A typical operator log, what cannot be captured in the laboratory and what is critical is also done through operator actions. So we take in the inputs which are not digitally measured through the operator logs. And these three streams then give us this holistic message. Here is a sample shot on how we can do comparison of different sectional parameters. We have a capacity to do right now for 4 parameters in a plant simultaneously. The analyst can do a visual comparison and impact analysis. This is a typical MIS input screens where we have further information to be provided so that the MIS input, which is meaningful and contextual for the organization, can be generated. All this in one application. So this is the typical type of reports which will be sent automatically through email on a daily basis. So this is the notification. And we got our RemoteBridge center. So we went ahead and established a RemoteBridge center for having customer experience, and also it will develop as a business champion training center. And it's also a remote team bridge center for analysis of our customers' operation. And we had it inaugurated recently, as recent as 1st of December. And RemoteBridge, that is reliability delivered for our customers. Thank you.